may lead code challenge. We got the problem of flood fill, which the problem statement says that an image is represented by 2D array of integers, each integer representing the pixel value of the image from 0 to 65,535. Okay, we have a 2D array, two-dimensional array of integers which have a range of this. Given a coordinate SR and SC representing the starting pixel, row and column of the flood fill and the pixel value newColor flood fill the image. So we already have a row and column, starting row and column given, with the newColor also is given. We need to flood fill the image. To perform a flood fill, consider the starting pixel plus any pixels connected four-dimensionally to the starting pixel of the same color as the starting pixel, plus any pixels connected four-directionally to those pixels also with the same color as the starting pixel, and so on. Replace the color of all the aforementioned pixels with the new color. Okay, it says that we need to start from the starting row and column, and then for each row and column we need to traverse all the neighboring pixels which are four directionally attached to it, and then we need to check that whether it is equal to the starting pixel color, and if it is equal to starting pixel color, then we replace it with the new color. It's like filling up with the new color which are for the pixels which are connected. At the end, return the modified image. Okay, let's see the example. We have an input of image is equal to this array, and we have a starting row of 1, a starting column of 1, and a new color is 2. So the output is this, which makes sense here, because from the explanation we can see that from the center of the image with position SRSC11, all pixels connected by a path of the same color as the starting pixel are colored with the new color. Note the bottom corner is not colored, this one, because it is not four directionally connected to the starting pixel. Okay, we have some note here which says that the length of image and image 0 will be range 1 to 50. It means that rows and columns are not more than 50, starting from 1 to 50. The given starting pixel will satisfy. Starting row is always greater than equal to 0 and image dot length, and starting column is always greater than equal to 0 and less than image 0 length. The value of each color in image ij and new color will be integer in 0, 65,000. Okay, the range of integers are always between these two. Okay, let's start thinking about this problem. There are key points which are valuable. There are key points which we can start thinking about. First, we have a two-dimensional array. Second, we need to traverse all neighbors of the pixels. For example, if SR and SC is given to us, what are the neighboring pixels we have? So we go here, and this is our two-dimensional array, and this is our SR and SC. What are the neighboring pixels here? This, which is equal to SR minus 1, and SC, and what is this? This one is, the row remains same and the column is decreased by 1. This one rows remains same and the column is increased by 1. Rows remains the same and column is increased by 1. And the last one, this one, and this one is SR plus 1, rows is increased by 1 and the column. Okay, we for each pixel we need to traverse these four neighboring pixels, and then we need to check whether the it is equal to the starting pixel color, and then if it is equal to starting pixel color we will replace it with the new color. This approach is called DFS approach, where we which is depth first search. And in this case we will start from the starting points, we will check all the four neighbors, we will check the color, and then for all those four neighbors we will again search all the four neighbors of that special pixels. Let's start writing the code. I will start with the implementation. I will first declare the rows. What are the columns? Let is equal to image length. And what is my old color? I will store it in a variable because colors will keep changing. Old color is equal to image sc. Okay, we need to write our function, which is called function fill pixels, and then it will just have all these parameters with old color. Okay, in this fill pixels we will check that if image sc is equal to pixels is equal to old pixels, old color, we will replace it by the new color. Is equal to new color. Okay, and how do we come to this function? We need to check if the old color is not equal to new color, then we need to call this fill pixels with all this parameter. Okay, this is my function which replaces the old color with the new color. What are the conditions of traversal? So we have to start with the traversal now. We need to check if SR is greater than equal to 1. What should we do? We should call this SR minus 1, and then we need to do the same for SC, and in this case we should call SC minus 1. Similarly for SR plus 1, rows, it should be less than, till it is less than rows we will go with SR plus 1. And then the last condition, control C, SC plus 1 is less than columns, then you just call this one should be SC and this one should be SB plus 1. Okay, at the end we will just return our image, return image. Okay, this is our solution. These four conditions make sure that you traverse all the neighboring pixels with the limit of between the rows. When the rows SR starting rows and starting columns are between the limit of rows and columns of the image. Let's try to run this program. I will remove all this. There is a runtime maximum call size exceeded. Why? And yeah, I'm sorry, this one should end here in the, where is it ending? This one should end here. Try to run it. Yeah, this one gives the correct result as expected. We don't have any other options to other examples to try. I will try to submit it and see. Yeah, this solution is accepted. Let's see the details. Yeah, your runtime beats 38% of JavaScript submissions. I will try to optimize a bit uh, of this solution. But how do you like this solution? I found it the basic implementation of depth first search, and let me know your opinion about it. Thank you so much.